Right, hi Year 10. This is a video helping you with clip 576, volume of cones on Hegarty Maths. So what I've done is I've kind of chopped a few questions out to kind of show you basically exactly what you need to be doing for each question. Now remember, volume means the 3D space that someone takes up, or another way of thinking of it is if that was a container, how much stuff you could fit in it, how much water would fit in it, things like that. It's all about capacity. So volume of cone questions come up every now and again, and it's usually to do with things like ice cream. If I have a 3 litre tub of ice cream and that's what the cone looks like, how many cones of ice cream can I make, and all questions like that. So the main skill here is we're going to figure out the 3D space that this takes up. Now the formula that you're going to be using each time is this one. Okay. Volume equals a third pi r squared h. Now hopefully what you can spot in there is that there is something there that you should recognise. Obviously a cone has a shape at the bottom there, doesn't it? What shape does it have at the bottom? It's a circle. And hopefully you can see, pens and pencils going flying here, you've got the formula for the area of a circle there. A third area of a circle times by the height. A third times the area of the circle times by the height. And the reason I'm highlighting that is tomorrow we're going to look at pyramids. And pyramids are effectively exactly the same as cones. They've just got a square, or a rectangle on the bottom. So this formula can then be applied to them. A third times the area of the bottom times the height. Okay. But today we're going to be looking at cones. So a third pi r squared h times height. So for this one, your volume is going to be a third times pi times the radius squared. Now look at the circle there. Distance from the centre to the outside, which is the radius. Remember that is 5, so we can just use that one straight away. 5 squared times by the height of the cone, straight up like that. Remember, not the slant height, straight up like that, times 8. And that's all I need to do. Okay, so I'm just going to put that straight into my calculator. A third, put the light on for this, I think. Yeah, a third times pi. Now remember, pi is at the bottom there. If you're using one of these calculators, it's in one of the function things, I think, on your Hegarty buttons if you need to use that. So a third times pi times 5 squared times 8. So my answer here will come up like that, 200 over 3 pi. But remember, this is asking me, give your answer rounded to one decimal place. This doesn't have decimal places in it, so I need to press the SD button to get it as a decimal. So my answer there is 209 point, and then we want it to one decimal place, which means we want to cut it off after that 4. And then because the first number straight away is a 3, it will just stay as a 4, not go up to a 5. So my answer there is 209.4 centimetres cubed, and we have to put a 3 because it's a 3D volume, isn't it? Okay, so that's questions 1 and 2 are exactly the same as that. Right, the next type is this one. Now you're going to be using exactly the same formula, so I'm just going to write that out again. Volume equals a third pi r squared h. Okay, you can't really see that very well, can you? Might grab a pen here. I'll just carry on with that for the time being. A third times pi r squared h. But this time there is one little difference. If you look at the difference between this question and this question, it's to do with the what you're given in terms of the circle, isn't it? The dimension, sorry, of the circle. So just be thinking about that. Okay. So a third times pi times, now we want the radius squared. 10 meters there is not the radius. 10 meters is the diameter because it goes right the way across the circle. We want the length from there to there. Okay, that's the radius from there to there. Well, if right the way across the circle is 10, from the centre to the outside must be 5, so it's going to be a third times 5 squared times the height again, which is 12, and then I just put that into my calculator again. So 1 over 3 times pi times 5 squared times 12, and that gives me 100 pi. And this time it's asking it for 3 significant figures, which again means it wants it as a decimal. So 3 significant figures. Now what this means it doesn't mean 3 digits after the decimal points. That would be 3 decimal places. It wants 3 digits from the start. We don't count 0 on that. But, oh sorry, 0 can't be the first digit, but it can be any other digit. We haven't got any 0, so that doesn't really matter. But our significant figures here are 3 will be the first significant figure, 1 will be the second significant figure, and 4 will be the third significant figure, which means we're going to effectively chop it off there after that 4. It's got a 1 straight after it, so it doesn't go up. So my answer there is just 314, and this is in meters, so it's going to be 314 meters cubed. Okay, so that's up to question, I think, 4. So your first 2 questions will be like that. Just put that number in there because that's the radius. The second 2 questions, questions 3 and question 4, will be like this, just half this number because that's your diameter, not your radius, and then use the same formula. Right, question 5. Now this one is similar to questions 1 and 2. It's just obviously flipped upside down. If you imagine sort of turning this around and you have that one, that's your radius there, that's your height, isn't it? The only difference this time is in how it's asked to be given. Give it in terms of pi. Now all that means is that when we get our answer at the end, you do not write it like this, you write it like that. Okay, so we're going to use exactly the same formula again. Volume equals 1/3 times pi times the radius, and this one is the radius, it's from the centre to the outside, isn't it? So times 6 squared times the height, which is 21. Put all that into your calculator. 1/3 times pi times radius squared times the height. So 252 pi. And we just leave it like that because that is in terms of pi, right? Which means it just has a pi in the answer. So that's questions 5 and 6 are similar to that. I think one of them you might get the same sort of thing, but then when you get it gives you a diameter again. So it's kind of like a mission match of the first few questions there. Right, and then question 7. Work out the volume of this cone, again in terms of pi. So we know what that means. It means that at the end of this, we're just going to have an answer with a pi symbol in it. We're not going to have an answer with decimals in it. But you should notice something about this question. There is something different about what you're given here. Can anyone spot what it is? Okay. Hopefully everyone spotted that it is the height. We're not given the height. Okay. This question is a little bit more where we do not know what the height of the cone is. That is that length down there. We need to know what that length is there. Let me see if I can. Now, given that I've just drawn that in, hopefully some of you might have spotted what we're going to have to use here. That creates a right angle triangle. And I know the base of the right angle triangle, and I also know the hypotenuse of the right angle triangle. So if I want to figure out missing sides, I need to use Pythagoras, which means effectively that I have a triangle that looks like this. Height is there, I've got 10 there, and I've got 6 there. So if I want to figure out the height, remember we have to use a squared plus b squared equals c squared. We're figuring out the shorter side here, so we're going to do this one squared, take away this one squared. Remember, try and put this all into your calculator at once. We're going to do the square root of 10 squared minus 6 squared. Put that into your calculator if you need to. Gives me 8. So that means 8 is the height of this. So I can put 8 centimeters in there. And now I can figure out the volume. So the volume will equal 1/3 times pi times your radius squared, which again is 6 this time, times by the height, which we calculated was 8. So times 8, and then put that into your calculator. So we're going to do 1/3 times pi times 6 squared. That way you can see it. 1/3 times pi times 6 squared times 8 equals 96 pi, and it wants it in terms of pi, so we're going to leave it like that. Okay, and then the last few questions are basically that sort of thing. But obviously sometimes you might be given a diameter, sometimes it might take a bit in terms of decimal places or significant figures. So when you're finishing these ones off, just pay close attention to the little details and have a little think back about which ones it was. Like if it's in terms of pi, if it says in terms of pi like these two, then it wants its answer like that. If it gives you a diameter across the bottom, then you have to halve the diameter. Okay. If it asks for one decimal place, make sure it just has the one decimal place there, and you use the above 5, round it up, below 5 it stays as it is. 3 significant figures, remember that means that you start counting from the front, not after the decimal point. So 1, 2, 3. So we chop it off there. Okay. So that's how to do the Hegarty maths part of it. If there's any issues with that, please let me know. Good luck.